Hi, how's it going? This is Ed with SGU TV. Today we're going to be talking about the Complement Cascade. Hey, how's it going? You're looking pretty good right there. Wait a minute, that's the wrong Complement Cascade. Let's get to it right here. This is actually the Complement Cascade you're looking at, and there's actually three pathways we're going to be talking about. The classical pathway, the lectin pathway, as well as the alternate pathway. So let's talk about these just in general so that we can get a big, broad concept of what's going on here. The classic pathway over here is actually adaptive. This is for the adaptive immune system. All right, so your body has reacting to certain molecule. You have an innate system as well as an adaptive system. The innate system kicks in first. All right, so this pathway is always kind of on at a low level, right? But the adaptive pathway, once it, the innate pathway, if you're exposed to like a germ or something like that, your body already has some inbuilt mechanisms to fight off that germ. Right? It just recognizes something called PAMPs, maybe pathogen-associated molecular proteins, things of that nature, and then it starts to kick off certain immune responses that will prevent that will actually attack those cells using natural killer cells, things like that. But that's not what we're talking about right here. We're talking about the complement cascade. So let's get right to it. So the thing is, we start with the classic pathway, right? We always want to start with the classics. We start with the adaptive immune system right here, and the thing is that this particular pathway here starts with C1q, right? Complement 1q. Now, actually, QRS is needed, right? And if you need an acronym or something to try to help you remember, queers, right? QRS, I guess QRS is standing for just letters, so I guess it's not really a true acronym, but it's just a little way that you could help you to remember. There's something a little bit queer about this whole entire complement thing, so maybe it helps you to remember. C1q will bind to the antigen-antibody complex. That's going to start the whole process of this thing kicking off. C1 attached to the AB complex, which is the antigen-antibody complex. We have RNS come into play. C1, now what happens is that you have information from C1QRS. C1QRS, and you're going to see this as a repeating theme, C1QRS actually is cleaving C2 and C4. So you'll see that usually when we have like chemical type stuff going on, you're going to see arrows like, you know, this thing is going to create this thing. But in this case, I've created a new type of diagram thing right here. You can see that there's a little line here, then there's a little fist here with a knife in it, right? It's cleaving, right? It's chopping. So C2 gets chopped. It has this, the C2 will go into two pieces. It will form a C2A and will form a C2B. The same thing is true for C4. Will form a C4A and a C4B. So the C2A and the C4A are going to be side products, and the C4B and the C2B combine, okay? This is also known as C3 convertase. And you can see what's happening is that once again, this product, which is also known as C3 convertase, comes down here and it's cleaving the C3 molecule. The C3 molecule is cleaved into C3A and C3B, surprise, surprise. Okay, throughout this whole entire pathway, everything's going to get pretty much chopped into A and B. There might be a little bit of a modification to that when we look at the alternate pathway, but for right now, it's a really easy thing to remember. Everything is cleaved into A or B. C3A, okay, you'll notice that I have C3A over here circled in blue with a little bit of red around it, over here as well, right? And you'll also notice that my C5A is also in this same particular pattern. Why? Because these molecules right here are, they will promote inflammation. So I just made it a little bit red, right, so that you could see that. This is actually going to be important when we think about some of the diseases that actually spawn from this particular pathway or this particular mechanism. So we'll get to that later. Just keep that in mind. This is something that's important to remember. So C3b, right, we said that C3 is cleaved into C3A and C3b. C3b attaches to the microbe, and then it fuses with the rest of the C4b, C4b2b, right, to form this piece over here, C4b2b, C3b. Look, I know it seems like a really difficult thing to memorize. It's not really cool at all. But if you remember the pathway, it becomes much easier to remember this thing. C4b2b, C3b, right? And then you have to look at it, right? And I can remember it just because I remember the other pieces that go on to make it. And it's nice because everything is B. So sometimes in medicine, things are super annoying. Like, you know, 1 will match up with B, and 2 will match up with C, and 3 will match up with A, and it's just like a big headache. But here it's pretty simple to follow. This molecule over here will cleave C5, and we're getting to the end. C5A, once again, we said was promoting inflammation. All right? C5B combines with C6, 7, 8, 9, and this forms the MAC, or the membrane attack complex. what's going to happen with this guy over here is it's going to go to the bad guy, right? The microbe, and it's going to cause a membrane attack complex, which sometimes called perforance. You're going to have the cell membrane, and then what's going to happen is going to put a hole in it, and then the cell contents is going to leak out, and then the cell will be destroyed. So this is one way that the complement cascade can help us to deal with microbes. Now, before we go to the alternate pathway, we're going to look at the lectin pathway over here, right? And lectin, how is it different from the classical pathway? Well, the thing is that it's very, very similar, right? We have this MBL, right? And we have the ficolins, right? These things that are causing the cleavage of C2 and C4, just like in this particular route, we form this thing and everything else after that is exactly the same, right? But the thing is that in this case, C1q is binding to the AGA-AB complex, the antigen-antibody complex. But in this case, right, these MBLs and the ficolins, right, mannose binding lectin, right, and the ficolins, they're recognizing certain carbohydrate patterns on the microorganism surface. And what's happening is that is actually activating the cleavage of these particular molecules going down this pathway. So this thing is just kind of, the way that this whole thing kicks off or starts off is just a little bit different. That's pretty much all you really have to remember about it. There's really not much more to it, okay? Now let's look at the alternate pathway. This is something just a little bit different and it's a little bit more involved, so let's talk about it. The alternate pathway, like I said before, is innate. It's always on just a little bit. And the thing is that there's different things that can actually affect the alternate pathway that can cause it to start to increase its activity. Gram-positive bacteria, right? Who's on gram-positive bacteria? They should have another video up, and I'll put the link in the description. Gram-positive bacteria, remember, have teichoic acid. And gram-negative bacteria, they have LPS, or lipopolysaccharides. And these particular molecules will actually cause the alternate pathway to start to cleave C3 spontaneously, as well as viruses and parasites and cobra venom. But you remember me saying that it's always on a little bit, right? These things, what are we always having cobra venom in our blood? That would be super cool, but it's not the case. We can see that also anionic polymers, right? That would be anything like, it could even be a protein that's not ionic. We have pure carbohydrates. You have some glucose running around inside your blood, and that will activate this a little bit. Sometimes you hear that carbohydrates are inflammatory. Could be because of this pathway right here. IgG, IgA, IgE, just a quick review. Immunoglobulin G, what is that? That's our general, right? That's the one that's most widely spread out throughout our body. IgA, right? That's a lot of times when you're studying medicine, you're going to see that things are numbered 1, 2, 3, A, B, C. And a lot of times, the first things that science has found are the things that are the most superficial versus deep. So it might be the skin, it might be your mucous membranes, things are on the outer surface. And then usually the things that are 2, 3, 4, or higher numbers or letters are going to be actually deeper, like maybe in your bones or something like that. So we have A over here, IgA, right? That's going to be inside of your spit and going to be inside of your mucous membranes, like outer surfaces. Not really so much in the skin, but more like things that are wet surfaces that are contacting the outside environment. IgE can be memorized by, you can say IgE stands for enemy, so that would be to fight off parasites. You have parasitic infection, worms, protozoas, viruses. Sound familiar? Yeah, it does. Okay, so IgE, right? That's going to be kicking off this particular pathway. So C3 is spontaneously cleaving. It's going to form with water. This is not always tested on USMLE, but I do like to be as complete as possible. But this is definitely tested on the USMLE, this fact that it combines with factor B and D. Sometimes they call it factor P, sometimes they call it propedrin, right? You got to remember these three guys, B, D, and propedrin, right? So remember alternate, right? And alternate. Why is someone alternate? Why is not the main guy? Because they're a little bit bad. BAD, right? There's no A there, but BD, right? Just help you remember B and D, bad thing, right? But then we have to turn around and get proper. So propedrin. Hopefully that helps to remember. Okay. What's going to happen is that these guys are going to fuse onto the surface of the microbe. Remember over here that there was a little bit of fusing to the microbe, right? The antigen-antibody complex. Well, here we're going to be fusing once again to the microbe. And then what happens is that we're going to form C3, capital B, and a small b, right? This one is also known as C3 convertase, but this one is actually less stable than this C3 convertase, right? And that would make sense because the alternate pathway is always on. Do we want it to be as strong necessarily as adaptive? Probably not, right? So, because if it was, then we would have all kinds of inflammation going on and maybe other type of immune responses. We don't always need that innate system to go off at full force. This is going to cleave the C3. Once again, we're going to have our C3A and our C3B. But remember I said there was going to be a little bit of difference. This C3A is not really C3A, it's IC3B, okay? This thing is special because this particular product, remember that C3B, okay, C3A does what? Inflammation, right? You see that little red circle around there? C3B opsonizes. One thing that, what does it mean to opsonize? Well, I think about it as optimizing, right? It's optimizing the microbe for to be acted upon by the immune system. So it's going to start to attach to the microbe and signals that, hey, we need to take some kind of action here. C3B, right? And over here, this C3B is going to combine to form C3BBB. Hey, I didn't come up with this. I'm sorry about all those B's, but it's just something you got to memorize, okay? Now the C3BBB is going to cleave another C3, so we have C3 being cleaved twice, okay? And we form C3B and C3A again. So just remember that it's alternate. Something's a little bit different here, right? You just got to have a little bit of a difference in the first step, okay? This C3A, once again, is promoting inflammation. C3B goes on to form C3BBB along with another C3B, and it goes on to form this, it goes on to cleave C5, which once again, remember, C5B through 9 is going to form what? The membrane attack complex. So once again, we're killing off the bad guys, we're killing off the germs, all right? So one thing that I have not mentioned that I kind of skipped over was the fact that this C3 right here, you see this amplification? This C3, the creation of C3 in this particular point will actually cause more of this to occur, and that will actually come into play later on once we start to look at some of the diseases that are related with this particular pathway. Before I get to the diseases, I just want to cover right quick some of the tests that we can give to see exactly what's going on within the system. We want to see if the alternate pathway is running. We run AH50. This particular test, which we test for AH50, you can run that as alternate H50. CH50 we run this test to see if the classical pathway is active. C, or classical H50. Or we run ELISA, which stands for, I believe it's enzyme. ELISA, what enzyme? Oh man, it's a very popular test. Enzyme, what is it? I'm gonna look that up. I'm gonna have to refilm that. ELISA, okay. All right, so before we get into talking about the diseases, let's talk about the tests. The test for the alternate pathway is, guess what? It's AH50. That stands for, A stands for alternate. And CH50, C could stand for classic, right? Classical pathway. CH50. So AH50, CH50, it makes sense. Also, you can run this test called ELISA, and ELISA stands for Enzyme Linked Immunosorbent Assay. So let's get to the actual diseases themselves. If you remember when I was talking about the classical pathway, I talked about C3A and C5A, and I said that those are inflammatory promoters. So what happens is that when we have something, a hereditary angioedema, what's going on is that you have a mutation, right? That makes sense because it's a hereditary disease. A mutation on the C1 inhibitor. So let's think about what happens if C1 is inhibited. We can't make C1. We can't inhibit C1, so C1 starts to go up. C1 is going out of control. C1 is being produced at a very high rate. What happens is, so now C1 is going like crazy, and then it's cleaving so much C2 and C4. So we're going to have reduced levels of C2 and C4. So in this disease, we expect to see a reduced level of C4 and C2. Also, what's going to happen is that C3A and C5A are going to start to accumulate, right? Because this pathway is spiraling out of control. It's just making so much of this stuff. This is pushing things down this pathway, right? And C3A and C5A, remember, are causing inflammation. So someone with hereditary angioedema, they're going to have all kinds of swelling going on. In fact, I'm going to, at this point, show a picture where you can see right here that this person has a lot of swelling obviously going on. Also, in this particular disease, we have factor 11 and 12 are promoted, right? And factor 11 and 12 are parts of the coagulation pathway. And to be more specific, you could check it out in this other video. that I'm going to put in the link in the description. But just the description, but the factor 11 and 12 is part of the intrinsic pathway. So it shouldn't affect the bleeding tests and things of that nature, right? What about bradykinin? It's an inflammatory mediator, so it's going to be promoting more inflammation, right? So these three things combined, right, you're going to see this person have a lot of swelling. There's no real histamine release, so you're not going to have like itchy swelling, but you will have swelling, possibly rashes, things of that nature. Okay? So let's move on to the other types of diseases that you can get. When we think about immune diseases, and one of the things that we think about is lupus. And in this case, we're talking about systemic lupus erythematosus. So systemic lupus erythematosus is noted by having, right, reduced levels of C4, right? So what happens in this case is that this is known as what can cause it is mild classical defect. In mild classical defect, we're going to have a less C4 being produced, right? Less of this being produced, which means that we cannot continue down this pathway. Now the thing is that C3, there's multiple pathways towards C3. Remember, not only do we have C3 being created by this, being cleaved from this pathway, right? But C3 can also be cleaved from the lectin pathway, and also C3 is floating around in the alternate pathway. So you have a lot of C3 floating around. So it's hard to really have reduced levels of C3. There is one instance where that can happen, but generally what we're talking about is reducing C4. Okay? So we have mild classical defect, and I actually have 4 diseases listed here, but I actually like to break them into 3 categories: mild classical defect, severe classical defect, and then alternative pathway defect. The mild classical defect I associate with CL inhibitor defect because both of these are notable for having reduced levels of C4. The thing about severe classical defect is not only are you going to have reduced levels of C4, you're also going to have reduced levels of C3 as well. And that just makes sense, right? You're going to have reduced C4 and C3. It's just going to be more severe. So other ways that this can happen is you can just have a straight up C4 deficiency causing reduced C4, causing a mild classical defect. You could have a C1 inhibitor deficiency. Remember before I said that if you have so much C1 being produced, it's going to be cleaving all that C4, so that you will have reduced levels of C4. Okay, and also hereditary angioma is also associated with this particular mild classical defect. And if you saw the picture, you could see that this person lived to a pretty significant age, right? It's not like they died in childbirth or anything like that. So I guess you could say it's pretty mild. They will survive to a certain point. Severe classical defect, that's going to be reduced C4 and C3. But let's get to the good one. This is going to be our alternate pathway defect. Our alternate pathway defect is noted for having reduced levels of C3. And actually over here, let me add that to my little thing here, reducing C4 and C3, right? Now the thing that we see about this particular pathway is very reliant on C3, right? So if we have something wrong with the alternate pathway defect, then obviously the reduced levels of C3 would cause problems all throughout this chain. So C3 here, C3 here, C3 here, right? 3 appears how many times? 3 times, all right? So, and if you're someone who's alternative, right? You're a friendly person, right? You're not the main guy, right? You're like that kind of a, maybe a alternate, maybe kind of a counterculture character. So you wave hi and you're friendly because people don't understand to accept you. So you say factor H and factor I are associated with alternate pathway defect. Or alternative, I think it's really alternate pathway defect, right? So either one is fine. So that is the Complement Cascade. I hope you've enjoyed. Please check out our other videos, and thanks for checking out SGU TV. Alright, that's it. Thanks for checking out SGU TV. Please make sure to like, comment, and subscribe, and check out our other videos.